Hi everyone, welcome back to our sessions. So as you know that you cannot take a large step at a time. Yes. So the basic is you have to take a small step, then you keep on learning. So this is same with the learning. You have to start with the basic as introduction, and then you have to get deep and dive. So when it comes to the tech stack, as we are aware of the fact that Akka has been commercialized, and we are looking for the alternatives. So for the HTTP, we have a good opportunity and good option, which is HTTP4s, and we already have a session on basic introduction on how the HTTP4s works and how to work along with the functionalities. What are the functionalities, advantages, how we can utilize those functionalities as a time. So yes, we are back with this session. I would like to invite our tech lead Swantika Gupta. She's tech lead in Nestec Technologies. So Swantika, the stage is all yours.
Okay, thank you so much, Kuldeepak. Hey everyone, good afternoon. My name is Swantika Gupta, and the topic for today's session will be HTTP4s, and hopefully we'll take a deeper step into how actually HTTP4s will be implemented in your projects and what all we can do with HTTP4s. So before starting and looking into the agenda, let's have a look at the knowledge etiquettes. First being punctuality. I will request all of you to please join the session 5 minutes prior to the session start time. Please keep your mobile phones, your screens on silent mode, and feel free to move out if you need to attend something urgent. Do provide constructive feedback as it is very helpful for the presenters, and avoid unwanted chit chat during the session if possible. Okay, so let's have a look at our agenda for today. We will be looking into majorly 4 topics. First of all, being HTTP4s. So as Kuldeepak mentioned, I guess in last December 22, we had a session on HTTP4s where we looked around into the basics of HTTP4s, what all can be done using HTTP4s. If you have attended the session, good. If not, no worries. We'll just take about 5 or 7 minutes to have a quick recap into what all HTTP4s brings into the picture. And it will be helpful in understanding the demo, which brings me to the second topic on our agenda, which is a demo using basic HTTP4s. Nothing fancy. How do we create HTTP4s routes? How do we create clients? How do we create servers? How do they interact with each other? Then since we already had a session of HTTP4s, this should be a good time to take a step further and look into something called as middleware in HTTP4s. And again, since we are learning middleware, the best way to learn is to try it out, do a hands-on. So the final demo will be a combination of those HTTP4s routes we created in the first demo plus what middleware brings more to those routes. So these will be the agenda topics. Moving on. So let's start with a very crisp recap. First of all, basics of HTTP4s. HTTP4s is a library, right? It has all the specific set of APIs functionality which can be used to create HTTP routes, can be used to create servers, can be used to create clients. But it is very, in very simple terms, it is very lightweight in nature. So you don't have to worry about a lot of other things. Just whatever HTTP endpoints you want to create, and what do you want them to behave as, right? Basically, HTTP4s is based on CATS and FS2 streaming, and both of these make it typeful in nature, right, which is very much important since we're working in a world of functional programming now. And because of these two dependencies, HTTP4s is very functional in nature. It's just purely functional in nature. And again, due to FS2, it brings in the streaming point of interest as well into the request body and the response body. So basically, using HTTP4s, you can either go the direct route, right? Do not include streaming. That's fine. But in case you are getting a response which is quite big in size, and loading them directly into the memory can be something which can be troublesome, right? It can lead to memory out of issues. So in that scenario, HTTP4s provides us streaming options in which the complete response body won't be stored in a memory, as and when you're picking up chunks of it, it will be loaded into your memory. So that's a good option. And all of these together, being typeful, being functional, based on CATs, giving streaming implementation, all of these together basically makes HTTP4s very performant in nature and a good HTTP library for Scala, basically, right? Now, HTTP4s, the heart of HTTP4s lies in something which is called as HTTP routes, right? It is a type which is created in the HTTP4s complete course library. right? And what HTTP routes is actually, in very simple terms, it is just a mapping of a request to a response, right? Then again, not every request returns a response, right? So we should modify it to maybe a mapping of a request to an option of response, right? And then again, since a response that you will generate, it won't be in an isolated environment, it will have to interact with databases, maybe other servers, so it will have to have some side effects in those, and those side effects, interaction with the environment, is something which is encapsulated by this F, which is available to us from cat's effect, right? So now our complete definition of HTTP routes is a function which maps a request to optional responses while interacting with an external environment, in very simple layman terms, right? And this complete definition is something which cat's library encapsulates in a monad transformer, which is called as Clasley. But if we do not want to look into what Clasley is actually, we are good, no worries. We just need to know for HTTP4s, it's at least that HTTP routes is the type which forms the heart of HTTP4s, and it is the mapping of request to optional response interacting with the environment. Okay. Another important thing which makes HTTP4s so easy to use and so intuitive to use is the DSL, right? So let's look into one example of it, very simple example. So we are creating HTTP routes for sure, because that is also the heart of HTTP4s, and that's what we are here to do. We are here to create routes. So how do we create routes? It's just a series of case statements, and every case statement actually is a endpoint. So that's all you have to take care of. Whenever you want to create a route, you'll have to create a case statement, specify the HTTP request type you're handling, whether you're handling get, post, put, delete, anything. So that will be your first part, followed by an arrow association operator and the actual endpoint that you want to hit, right? So in my first case, I want to hit something like my localhost / colon port / length / a parameter that I want to pass. Or in the second scenario, it can be /hello / parameter I want to pass. So this is my actual endpoints that will be exposed by this particular route. And then finally, once this route is hit by a client, what is the behavior that needs to be implemented? It forms the rightmost part of the complete case statement. So in my first case, I want to calculate the length, or I want to return the length of whatever parameter we are passing. Or in my second case, I want to return hello followed by whatever parameter I'm passing here, right? So this is how you will create a simple route definition, and it is not just limited to get, right? I informed it also includes post, put, delete, whatever you want to try out. You can have a series of all those case statements here. Not only that, you can create 2 or 3 separate routes, HTTP routes, route 1, route 2, route 3. You can combine them together. You can ask one of the route to hit the other route. So all of these compositions you can do together, right? Now, the thing is that in this, whatever route we're working with, here str and here name, right? These two are something which is called as path parameters, right? And by default, they are string, they are of string type, right? And like probably it is something that you do not want to work with. You want a conversion type of scenario, or you want to handle those path parameters. Actually, you do not want to just work with strings. You want to convert it into other types, right? So this is where the DSL provides us certain extra extensions as well. First of all, let's have a look at this example. So as I informed earlier, this is a case statement, right? So my actual endpoint would be /weather /temperature / a date probably, right? And this is a get command. So when this endpoint is hit, by default, the date would have been string. But I do not want to work with string. I want it to implicitly convert or implicitly work without an extra handful of knowledge to a valid date type. Okay? Sorry.
Anand.
Okay, so for that to happen, what we have done is we have created an object, local date var. We have specified an unapply function, which actually takes in a string and does some logic on it. So in my case, what I'm doing is, if it is an empty string, then I'm passing none. And if it is a string, like any parameter is passed, I'm trying to convert it into a local date and into an option. If it fails, none. If it does not, then we're good, right? In any scenario, I'm handling this path parameter and not working with just the string representation of whatever path parameters it is passing on, right? And after that is done, I am having my response that if it is a valid local date, if it is a valid date actually, then I want to implement get temperature forecast for that date. It's an API. It's a business logic that I've created that will get me the temperature for a particular date. right? And if it doesn't work, if let's say my date format is wrong, or if I've not passed my date, in that scenario, this particular endpoint will be hit and it will return a failure saying this does not exist, right? Okay. Apart from handling these path parameters, we have certain other set of matchers as well. We'll just quickly go through these because this is something which will be used in the demo part as well. So first of all, we have query param decoder matcher, right? So a lot of times you must have tried to create HTTP routes where you specify certain parameters as a key value pair. So I want to create this endpoint where I'm passing year equals to 2005 or some other year, right? So what my http4s, using my http4s library, what I can do is extract the value of this year directly without any extra set of code, right? Not a lot extra set of code, and maybe validate it or whatever I want to do it. Okay, so this is how I've done it. I've created a route slash weather slash temperature. Up till this point, this is same. And then colon question mark followed by a param decoder, right? And this param decoder is something that I've created on my own. So if you'll have a look, it is an object air query param matcher, which is extending this decoder matcher. And as a field of this query param decoder matcher, I'm passing year. And this field should match whatever key you're passing in your API, in your endpoint as well, right? So once this is matched, its value is extracted, and I have an implicit value here. What it tries to do is it tries to convert this whatever value we're passing here into a year format if it's a valid year, right? So this is what is happening here, and this all can be done by just having this air query param matcher or any kind of decoder along with the API endpoint. Sorry. And if it works well, then the function will be hit, everything should work fine. But if it doesn't, then we'll get an error in that scenario, right? Now quickly moving on, again we have the optional query matcher as well. I'm not going to read the complete name, it's quite long, so let's just keep it to optional query matcher. In this scenario, we want that our endpoint may or may not have the param that the code is looking for, and we want it to handle both the scenarios. So my endpoint where temperature question mark air equals to 2005 and my endpoint slash temperature without any extra parameter should both work fine. And this can be done using an optional query matcher. Again, specification remains the same. We specify the name of the key along which should be the same as the one that we're passing in the API. The only difference being here that this is the query param decoder matcher, that it is supposed to find here. If you do not pass here, the query will fail, showing that no matching endpoint found. But in this scenario, we are providing it a flexibility of being optional in nature, that it might or might not be present. In case it is present, after this validation is done, it is converted into, checked whether it is optional in nature or not. If it does not exist, I'm calling an implementation which finds for my current year. But if it does exist, then I'm calling for a particular year. So my implementation can be changed based on this. So the scenario of this particular endpoint to fail, if I'm not passing a parameter, is a little less here, unless and until I screw up and change the complete endpoint itself. But yeah, based on whatever value I'm passing here, whether or not I'm passing it, this should work fine. Now, sometimes you might want to have that parameter fetched up, and you want to validate it before sending it to your behavior part of the code, right? And you want to handle the validation in separate scenarios. A failure case where the validation did not go fine, the input parameter was invalidated, and you want to handle it in a separate way. And if it is validated, you want to handle it in a separate way. So that is where the validating query matcher comes into picture. Again, our final API endpoint, it remains the same, temperature question mark year equals to 2005. Just we have created a new object here, air query param matcher, which is actually extending the validating query matcher. The basic specifics remains the same, that the name of the field should be the same as the name of the param in the endpoint. It's just the implicit that we are using here, it gets changed, right? So what it is trying to do is it is trying to parse whatever year I'm passing into a valid year type. And if it is able to do that, good. If not, that I'm returning a parse failure. So I can have a validated result or an invalidated result. And based on that, in my behavior part, I'm handling both the scenarios. That if my year, what I'm passing, returns a failure, then I want to return a bad request. And if it works fine, then I want to go on with my actual implementation, right? And finally, I won't go deep into it, but as the name suggests, I hope it is something which we can read together. Optional validating query param decoder matcher, and the name suggests that it is a combination of being optional as well as validation. So let's take an example. here is my API where we are passing long equals to 13 as a param, right? And it is something which we have passed in my optional validating matcher as well. So this means that first of all, this API should work fine, this endpoint should work fine, and if I do not pass this endpoint long equals to 13, then also it should work fine, specifying the optional nature of it. And as far as the validation is concerned, what I want to do is that I have specified that this long param should be of type long. So it is the validation that is happening here. If it is not of the type long, then it will return a parse failure. Again, I'm responding with a bad request. And if it is of type long, then I'm going with whatever implementation I want to go with. So it is basically a combination of both optional and validating. Okay. Up till here, do we have any concerns, any questions, any doubts? Okay, let me then go ahead. Okay, finally, this is the last part of the recap. This is the place where I specified that Http4s can be used not just to create routes, but to create our servers, to create our clients. You don't have to go looking for other libraries, right? So basically, there are Http4s supports a lots of libraries. Like you have Ember server or Ember client. Those are one of those that I have tested in my demo. Apart from that, we have Blaze and many others. Whatever you're comfortable with, you can try with that. For my demo, I've used Ember. And the implementation wise, it is quite simple. So in my server, for creating my server, it's just the Ember server builder. I specify the host, I specify the port, and I specify whatever routes I want to hit. That's it. And for my client, it is even simpler than the server. I just have to create a builder and create my functions or hit the particular endpoints that I want to test with, right? So very simple to create servers and clients. Now, before we go on with the theoretical part, it's very important that we have a look on at the code that we have so far done, right? Let me just close all of this. I don't want to spoil the secret here. Okay, so just let's have a look at this directory structure right now. So this is our repo, hands-on with HTTP4s, right? In it, we have two modules. One is the client and the other is the server, right? And if I have a look at my build.htt, the dependencies, those are very similar. Like you'll find it in any documentation very easily. It's most related to HTTP4s, DSL, Ember server, because I'm going with Ember. If you're going with Blaze or any other, you'll have to change the dependency here. Then the type safe config is fine. And another thing that is here is the circe library that I'm using. So what I'm using circe is for serialization and deserialization of my request and response body. That's it, right? So from converting to JSON to case classes and vice versa is something which is taken care by the circe library for me. And that's it. No other extra libraries are being used. Okay, so let's have a look at the server first. This is the basic code of how the server is looking. We are using IOApp. Since we are working all with cats effect, we are using IOApp for creating our object. Basic set of code sets just to create the server, get everything in place to start the server. We'll have a look at the definition of server, as I mentioned in the PPT as well, right? Just the host, port, and the service. Now, what is interesting is this particular set of code that we've written to create that HTTP routes. So like I said, you can compose, right? You can add one route to another. You can specify all of these things. So this is what we have done here. We have created one set of routes here, health check API, and then another one, user service API. And we have added them together using this operator, the combine key operator. So this will make sure that whenever the server is up, both of these routes should be available and any can be hit. And if the hit endpoint does not match any of this, then a not found exception will be given back to the server, given back to the client. So we're okay there. Okay, let's have a quick look at the first one, the health check API. Very simple in nature. We have just created a single case statement where it is a get type of HTTP request. Endpoint to be hit is /health check. Using this health check, what is happening is on the behavior side, we are returning a case class of health check status, which basically specifies that the server is up and how long has it been running for, right? And using this response, what we've done is just created a JSON of it. This as JSON is something which comes from the circe library to convert whatever case class we're working with into JSON, right? And we respond to the client request using the OK envelope, specifying that this request is handled by my server. Okay. Since we had a look on this one first, let me just quickly take you to the client now. On the client side, again, we have a runner, right? The same thing, extending IOApp. Client definition is pretty much simple. Ember client builder, default IO build. And using the client, we specify this first endpoint call. And if you look at this particular health check method that I've created, Using the client, we are trying to hit this URI, right? And what this URI is basically HTTP localhost port followed by health check. And what is it expecting is a string format. We are expecting the result in the form of a string here. Okay. So ideally, if you look at it, the client is hitting /health check, and the server is returning. Sorry, I lost my code there. The server is returning a response for that health check response. So it should work fine, no issues at all. Now, before I show you the working demo of it, what I want to do is give you a glimpse of what all we are doing in this code. So what we have done is we have created a CRUD application for users, right, in which we can add user, query number of users, query a particular user ID, delete a particular user, or update information for a user. So basically, I've tried to handle all of these different types of method parameters, right? So the get command, post command, put command, and delete, right? Okay, so let's first look at this one. This particular endpoint, that is /users/ either you can pass sort equals to ascending, or you can pass sort equals to descending, or you cannot pass anything. Okay, that is our choice. So to handle that, like I was mentioning in the PPT, we have created an optional query matcher, right? We're matching the parameter sort. And if I quickly take you to the client as well, get all users, yes. So this is the final API that we're trying to hit. If in my method I'm giving a sort order, then this particular endpoint will be hit where sort equals to whatever value we're passing. And if not, then without any sort param should be hit as well, and none should give an error, right? So this is handled using optional query matcher, right? And from the logic of it, very simple logic, based on whether it is passing ascending or descending, we are trying to find all the users on the basis of the username in descending or ascending order, right? And I forgot to mention this actually. Right now we are not accessing any database. Just for demonstration purposes, we have created an in-memory map for this user, where every user ID maps to a user information. So if I hit my get all endpoint, then I should get a list of all of these users, right? Then again, if you want to find out one particular if I want to find out information for one particular user ID, then my exposed endpoint should be /users/ the user ID that I'm passing. And I mentioned, right, this user ID is supposed to be string in nature by default whenever it is called. So now I need to do one thing, that I want to convert it to long. So this long var, it is something which is already given by Http4s. Some of the commonly primitively used converters, those are given by Http4s on their own. But if we want to work with, in my example I showed you, right, if I want to work with, let's say, date, and this is something which is not given by default by the Http4s, so in that case I'll have to create one extractor. But this one is given directly. So ID by default will be string, and after converting into long var, it will be completely in long, right? And in my functionality, it's the same thing. I'm just returning my user based on getting the value of the ID from the map. Implementation wise, it is very primitive in nature. Okay, and I did mention, right, how we are calling it. Again, we are expecting a string, and as far as the URI is concerned, /users/ the URI that you want to hit, right? Now, where actually, when I was working on this demo, where I had to do certain research and find out results for me, was the post command. Once I got a handle of the post, the put and delete were easier to do with. But yeah, the post was something that was it took some time to understand. So for the post request, this is how we are creating the request. We are creating a request IO, where we are specifying that the method is post. By default, the request IO has this method as get. Okay, method.get is the default one. So method post, and we are passing a URI here. Okay, and this is the URI. And since it is a post command, it is supposed to have a body as well. So we are passing a JSON with entity, using with entity API. We are passing a JSON containing all the required information: username, email, and age. And user ID will be calculated by my business logic. So that's fine as well. So when this post request is hit, I have my request here, which is actually request IO, the one that I'm creating here on my server side. And I can decode my request in the form of a user form. So user form is nothing but my case class implementation for the JSON that I'm sending as a part of my request body. So it's same thing, username, email, and age. So once it is decoded fine, then I am just doing simple logic of creating a user ID, creating a user complete service, and adding that particular newly created user to my implementation of in-memory implementation of map. So that's what it is happening here. So for handling post request, the implementation changes a bit, that you'll have to specify a request IO. You can do the same for get as well. I'll show in another part of the demo. But for post as well, you can just specify the method, the URI, and whatever new extra things that you want to go ahead with, extra parameter, body that you want to add here in the form of JSON probably. So that is something which is done here. Then similar for the put as well. If I show you the put request IO, creating a type of put, right? Creating a URI where I'm specifying my user ID to update. So this put command is put request is basically supposed to change the age, right? So that is what I'm trying to do. So this is the body that I want to work with, that for my user having user ID, whatever I'll be sending here, I want to update the age to 65. So this particular implementation takes care of that. On the code side, on the server side, implementation is pretty much simple. Similar as to post. From the request, I convert a user age form where I'm just sending the age, right? And then I have an edit option available here, edit implementation available here, where if I get a user matching the same ID, then I'm updating its age to the one that is being sent from the endpoint. And if not, then I'm raising an exception. And finally, the delete one. Again, for delete one, again, request IO, specifying delete method, URI. Since it does not require anybody, so no extra implementation is required here. Just the user ID is being sent, right? And in my implementation on my server side, yeah, I'm converting that ID again into long type, and I'm calling the implementation or behavior for removing that particular ID, right? So these are all that are happening here. Just to show you a working demo of it, let's try that out first. Let me maximize the screen. Okay, we are in server and we are starting up the server. And similarly, we are in client and we are starting up the client. So basically in my client right now, I have specified, I have hit all the endpoints, like one after the other, so that we don't have to go back and forth updating. Okay, so the first endpoint that we hit was health check endpoint, and it should return me a string, specify the status, specifying how much time has it been since my server has been up. So this is the response that I'm getting. Second endpoint, I'm trying to get a particular user information for a particular user ID, right? I've called the get user function, passed on my client and the user ID to fetch, and this get user is actually hitting this endpoint, and I'm trying to work with one, so that this is something which is already preloaded, right? So for this, I'm getting all my data point, right? Then just to show you how it looks like, I have called a get all users endpoint to see all the users which are being passed, and passed sorting order, descending sorting order. So once that is done, we can see this one, where this is arranged on the basis of the descending order of the name, right? So J before A. So we get an initial list. Then we're trying to add a new user here, and once after calling the add user command, I am getting this response, user with a new ID, which is randomly generated, 229 created. And then I'm calling again the get all users just to see whether it is added to the map or not. So as you can see, yeah, here it is added, 229. Okay, this is the first one, the second one, and then 229. Now in my next request, I want to update the information of one of the users. The user I'm trying to work with is 1. So for user ID 1, I want to update the age of the user, as I mentioned in my code statically, to 65. So originally, user number 1, user ID 1, had age 29. I hit my put command, and after that was done, I tried to fetch it again. And for this one, the user for ID 1, its age has been changed to 65. Right, and finally, the last one is to delete a particular user. For deleting a user, again, I just want to delete user ID 2. And after deleting the user, I'm trying to get all the users again. And I get a response first after hitting the user delete endpoint, that user list after deleting user ID 2 aisa ho gaya. And after that, we have a list of all the users apart the second one that we have deleted. Right. Okay. So this was the first part of the demo. Any questions up till here? Okay, taking that as a no then. Moving on, the very next, the plus one to whatever till now we have learned about HTTP4s and its routes. This is something which is called as middleware. So middleware is basically an abstraction over a service. It is a wrapper over a HTTP route service that we are creating, and it is a function which takes in input as a service and creates a new service. Right? Middleware is not actually something. It is not an implementation wise thing. It is a logic where we are trying to create a middleware over our services. So for example, right now, what I in the demo that I showed you, what we are trying to do was we created different endpoints. Right now, let's say in those endpoints right now were unauthenticated. Right, anybody could hit it. Right, but in future you might want to create authorized endpoints, right, where you want to validate whether the username or the session ID which is hitting that endpoint, it is authenticated or not. So that forms a middleware over my actual HTTP route service implementation. Right, so that is where middleware comes into part. A very very simple example to understand it would be that right now when I hit my endpoints, any endpoint, then there are no extra headers that I'm getting. It mostly it would be just content type equals to application slash JSON. But what I can do is for every response, successive response that I'm generating, before sending it back to the client, I want to add certain extra headers to it. So this step of adding extra headers to it is a middleware. Right, so I'll show you the demonstration for this one as well, but let's take an example here, that this is a add headers middleware which takes in a service as an input, that is HTTP routes as an input, and returns in HTTP routes. Okay, and for calling this add headers, I'm just passing my API here, and whatever new headers I want to add it, I'm passing it here. Right, so this is something of a custom type, but then there are certain middlewares that are provided out of the box in the HTTP4s core code base itself. So we have certain set of middleware for authentication using basic auth mostly. Right, then we have for cores for response compression, that if you want to compress your responses to gzip, you can do that using middleware which is already provided out of the box by HTTP4s. If you want to implement metrics, Prometheus metrics probably, that is something also which is supported out of the box by HTTP4s. And if you want to go ahead with loggers, right now, let me just show you that directly. Right now, if you just saw, we did not have any loggers on our servers, extra loggers, that our endpoint is being hit or not, and nor did we have it on the client side. These were the ones that I printed specifically just for understanding purposes, right? But no extra loggers are present, are shown in my actual implementation or basic implementation of HTTP4s routes. So in order to handle that, the code base provides an out of the box loggers implementation as well, using which you can have a look at all the different logs that you're seeing. Okay, actually in my code base, for the demo purpose, for my code base I had created separate branch. Let's have a look at the middleware first, and let me get the server started and the client started as well. Server, and we have the client here. Let's first look at the code here. What we have done different here is, so in my code base, if you can see, I've added a middleware package here, and this is a header middleware object, and we have given an implementation add middleware which takes okay, let me just show you. So we have created a header middleware object with an apply method which takes in the routes, right, whatever APIs that we have exposed, whatever endpoints we have exposed, we have those routes, and if those routes which are hit, they return successful responses, then we are mapping it to add headers. Okay, and add headers is a middleware that I've created. What it does is that if the response is successful, then I'm adding my headers. If it's unsuccessful, I'm not doing anything basically. Okay, and if you look into the code base, where we have used this is the server side. In the server side, so what you can do is, like I told you, right, I have two different endpoints, user service endpoints and health check endpoints, and I want to do this adding extra middleware or adding extra parameters, headers to my responses only in user service API. So that I can do it in such a method. My health check API, it is not covered, not wrapped around by any extra middleware, while my user service API, it is wrapped around by my header middleware. Okay, and I'm passing a list of extra headers which needs to be added here. So if I call this header middleware, it will go to apply method. Apply method will make sure that the service is mapped and has extra headers added to it if after calling that particular endpoint, it returns a successful response and nothing if it returns nothing else. Okay, and on the server side, on the client side, I have not added extra anything. It's just I wanted to show you how the headers look different in a API which is surrounded or which is covered by middleware and the other one, right? So right now I'm just doing this. I'm calling health check, which does not have any which does not have the middleware around it, and I'm printing its headers, and then I'm calling one of the user service API and printing its headers, uh, and making sure that those are different, right? So let's try that. I have my server running. Good. I just want to run my client. Okay. Oh, something happened. Connection refused. Did I do something? Okay. Let's try again. Okay, so this is the result. This is the result from hitting the health check one that did not have any middleware. So if you look at its headers, there are no extra header added, right? These are the ones that are generally exposed by any basic HTTP route. So date at which it was hit, connection type, and content length. But in my second implementation, where I'm hitting an endpoint which has a middleware around it for adding extra headers, I'm getting new headers in the configuration. So any endpoint that I hit from the user service will have these extra headers. Okay. Just again, I want to switch to another branch. So this is the one which I've created. And this particular branch contains code using authentication. So it should not take a lot of time. I guess somebody's okay, cool. Okay, so let's look at the code changes that we did here first. Let's look at the server. Let's go to server, combine roots. Okay, again, logic wise, it is pretty much simpler. Simple in the sense, whatever changes are required on the server side, those are same. If whatever middleware you're using. So for my custom middleware, it was also the same. For this authorization middleware is also the same. So health check API, no middleware. But my user service API, it is surrounded by a middleware. And what this middleware is, basic auth middleware that I've created. Let's go here. Here, what we have done is we are trying to do we are trying to do authorization authentication using basic auth. Okay, so basically what we're trying to do is we are specifying a username and a password. This is all just for demo purposes, right? In actual implementation, you will probably fetch the username and password from the cookies or probably somewhere else, but that's not what we're doing here right now. So I have statically added my username and password here, right? And I have a validate password method defined where I'm trying to check whether the username and the password being passed from my route, those match the same variable names or not. And if it does, good, I'm going ahead. If it doesn't, I'm returning none, right? And this basic auth is the implementation which is provided directly by Http4s itself, right? And it we just specify the mechanism that should be used for validating whether the user is whether the user is authenticated or not. Okay, now on my client side required certain changes to be done. If you remember, okay, let's look into this one directly. So these were my all the implementations that I was using earlier, right? So this is the get command that I'm calling, get HTTP request. Then I'm having my URIs. But apart from all of these things, whatever header, whatever body I'm passing, whatever I'm doing, apart from this, now I have to add headers as well, right? And the header should contain an authorization. An authorization should have the username and the password that I'm trying to test. So let me just try doing this. Let me just first remove this one. Okay, and I have not changed, sorry, I have not changed what do you call it, the server, right? just the client part of it. So what I'll have to do is I'll have to restart the client. Okay, I have not done so. So we're good. I think I did hit it, and I think I have provided wrong username and password. Okay, good. Okay, so right now I did not give any authorization for my first call, right? And it returned an error specifying unauthorized, right? It requires certain authorization, and it is not happening. Now, let's do this. Where is it? Now, I want to do everything, but with authorization. Let me just check what was the name, what was the username and password that I was basically working with. Username 1 and password 1. Let's come back to my client. Username 1 and password 1 I'm working with, right? And I have specified everywhere whatever my headers are, authorization, basic credentials, and now let's try running it again. Okay, now we are able to hit all of these endpoints, and they create, the right responses as well. Just to get you look into, just to have you guys look into it. This health check API, it was also hit, but since it was not under any kind of authorization middleware, so it was hit fine. Like no authorization was required. It worked fine. No error came up at this point, right? Even when we were doing no authorization or we were creating wrong passwords. But the others one, they failed, right? But now since we've given the right password, right, everything is working, also working fine. Okay, so right now basic auth is one of the authorization mechanism which is supported by out of the box supported by http4s. But yes, you can use any of the other mechanisms that you want to try with other libraries. Like a lot of them are supported. tsec, for example, is one of the mostly used library for authorization with http4s, so you guys can try out on that as well. Okay, I guess we are right on time. In case anybody has any questions for me, probably we can discuss.
Guys, do we have any questions?
Guys, if you do have any question, don't hesitate. Please raise your voice and ask. We will best to answer your questions. Swantika, seems like we are good to go. Still, someone have any question? You can reach out to us on MS Teams. We will be happy to answer you. And Swantika, thanks for this wonderful session. There is a number of things which I have learned about, especially. So there might be some, key points to take away, and I will try to implement them as well. If facing any issue, then definitely I will get back to you. So thanks everyone, and I would like to encourage if anyone to have any feedback, please come and please speak up, since your feedback is very helpful for us in order to improve our sessions as well. And thanks Swantika for this wonderful session.
Okay, thank you guys, everyone. I hope you find the session interesting and you will be, trying out http4s. Again, as Kuldeepak mentioned, in case you guys face any issues on setting up the system or require any assistance from my side, please do let us know. Thank you.
Thanks,
Thank you everyone. Have a
Vantika.
nice
Thanks,
weekend.
Kuldeepak. Thanks, everyone. Thank you.